So we're going to talk about documentation, and yes, it is 5 p.m. and we are going to talk about documentation. The most riveting subject on the entire planet, particularly for agile teams, right? So, for those of you who didn't come to my talk this morning, I'm Simon Brown, and I live here in Jersey, in the Channel Islands. And we're going to see some photos of Jersey later, actually. So I've got some photos in this talk to liven up a bit. I talk about software architecture, I do training and consulting around software architecture, and I also write some code. And there's also a book. So if you want any more information about creating documents for software projects, it's in the book, it's also on the website. Right, where did they get this from? Agile Manifesto. What's most people's interpretation of this? No documentation. Those words do not appear on this picture, do they? The Agile Manifesto doesn't say, don't write any documentation. But this is how a lot of teams are perceiving this. And I think a lot of software teams have a duty to deliver documentation, particularly those that are, outsourcing, consulting, or building things for another organization. But it doesn't happen because it's boring. And the Agile Manifesto says, don't do documentation. So here's a screenshot of Visual Studio. And this was my first .NET project when I moved back to Jersey. And I hadn't done much .NET work. In London, I've been doing Java for like 10 years. So this was fairly new to me. And I was asked to go and join the team and start delivering features. So I've got a number of learning curves here. First of all, the technology's new. And secondly, I don't know what this is. I don't know the business domain, the application functionality, and so on. Now, when I joined this project, there was no documentation. So I really was on a steep learning curve here. So what do? Well, thankfully, even from this single static screenshot, we can tell a number of things about the application here. There's lots of C# code. Hooray! There's this thing over here. So for those of you who aren't .NET developers, these are Visual Studio projects. And this one I've highlighted is called ib.web, internetbanking.web. So this was an internet banking platform. And you kind of expect that. It looks like we've got some layers here, some tiers. We've got something called ib.middle tier. But I don't know if these are logical or physical tiers. And it looks like we've got a number of different libraries. So we've got some class libraries, and there seems to be some naming convention going on here. But again, I'm not sure what these things really are. This folder here, called service references. For those who aren't .NET developers, essentially these are web service clients. So it sounds like we've got a distributed application, web tier, bunch of web service clients, some middle tier, web services between the two. But I've had to work hard to get to this point. If there was a document, some diagrams, it would make my learning journey much easier. I showed you this picture earlier. I think a lot of teams are in chaos. This is the slightly more animated version of the picture. This is what crazy teams are going on. So, as I said, a lot of teams don't understand, first of all, what they're building, and secondly, how they're going to build it. And sometimes they don't even know how they are building it. Teams can't explain what they're doing. And we need to stop all this. Why? Because bad things happen. I did say this is the crazy animation show. So we've got big balls of mud or systems that don't work. How do we stop this traditionally? Big documents. This is my whole relay sport thing this morning. A solution architect comes along, delivers a big document, no one reads it, so the shared model we're creating there is essentially this. Too long, didn't read. But we don't do that anymore, because the Agile Manifesto says, don't write documents. I'm reading this right, aren't I? Don't write documents. No, I'm not. But this is, of course, what a lot of people think it does say. And therefore, our shared vision is now WTF. You know, there is no shared vision anymore in a lot of teams. Who's heard this term? Tribal knowledge. A few people? A couple of people. So, in a lot of software teams, people work in silos. And you know, if you want to go and add a new database table, if you want to go and add a new service or component, there's one person on the team you need to go talk to. You know, this person's a guardian of all that knowledge. Agile says communicate, collaborate, let's talk. Rather than exchanging big, hefty, big documents that nobody reads or cares about. But what happens when these people leave the team? All that knowledge disappears. And there's something called the bus factor. And the bus factor isn't just about buses though. So it's about trams, aeroplanes crashing, let's hope that doesn't happen, and a number of other situations where people disappear. So let's try that on our team of 5 people here. So one gets run over by a bus, somewhat fortunate. This one goes on holiday. This poor guy gets fired. Do you want to see that again? Okay? Ready? Bus or tram. Holiday, vacation, fired. Bye! So now we have 2 people left on the team. And I've actually worked with teams where this has happened. They've not been killed or anything, but people have left, and that knowledge has also walked out the door. And then you hear these funny conversations happening. You know, how does this component work? What component? I didn't know we had that component. Great. So agility is trying to make us go faster by collaborating, but now we're going slower. Fail. Right. So that's the frustrating bit again. We're done now. We can do the happy stuff. So I'm going to take you on a quick journey. Let's imagine I've got some cool teleporter machine, and I zip you all away to some far-flung location. And you end up here. Where are you? Alice in Wonderland. Not quite. Almost sometimes. I do think that. In a park. So this is close. This is a little country lane in Jersey. So you would never ever have guessed this. How do I know that? I live there. I took a photo of Google Maps and Google Earth. But you guys haven't been there before. So let's imagine I did plop you down on this lane. How would you discover where you thought you were? Ask someone? Okay, there's nobody here. Explore, so exploring is a very good idea. You know, have a wander around, but maybe it's just more of this. Scream a bit, there's nobody around.
Ask Google.
Yes, see? Bunch of techies. Ask Google. So you get your phone out, you fire up Google Maps, and you find out where you are. Brilliant. So what does Google Maps show you? It shows you this. Does this help? A little? Yeah, so we can see some road names now. We can see there's lots of countryside trees here. But it's giving us some additional context. But in order to really know where we are in the world, we need to zoom out further. So let's do that. So we're in Jersey. Surprise, surprise, I live in Jersey. Treasure Island. With no treasure. So that's a picture of Jersey. Now for the people at the back, does this make much sense? Does it look quite complex? It's a bit complex, isn't it? There's a lot of detail being shown here. This is the problem with the kind of satellite view. So what we can do here is we can strip away some detail, and this might make the picture easy to understand. So let's do that. There we go. So now we can see the major structural elements, can't we? You know, we can see things like the airport, We can see the major roads. We can see the shape of the island much more clearly. So this is a nice overview. Who knows where Jersey actually is? You do, because I showed you like 10 slides ago. So you have to zoom out even further. So this is Jersey here. This is the top end of France, Normandy, Brittany. Zoom out a bit further. You realise it's down here. This is the UK, Belgium, the Netherlands. Zoom out further, we get to see Europe. So we're zooming out, zooming out, zooming out, and we're losing detail. But it's giving us a really nice context. So I live here, look, 3 pixels. So what does this have to do with anything? Let's go back to software. As I said this morning, we're great at visualizing our process now. You know, Kanban boards, storyboards, post-it notes, work in progress limits, swim lanes within swim lanes, all that kind of stuff. But we can't draw pictures of the software we're actually building. I also said this morning that if you want to be agile, if you want to move fast, if you want to deliver value early, get feedback, you know, that requires very, very good communication. So we do need to be able to communicate well in order to move fast. So we need to learn how to draw pictures. And as I said earlier, just create some understood way of drawing pictures within your teams. You know, whether that's UML, that's fine. You can use something like this. So a software system made up of containers, made up of components, made up of classes. Could be modules, functions, whatever you want. And then just simply draw a diagram at each level of abstraction in turn. So we start off with a nice big picture context diagram. You know, here are the people using our system. Here's our system in the middle, and here are all our key system dependencies. That's a very zoomed out map. Then we can have a technology specific view, which shows the containers that we're using, you know, the web server, app server, database type thing. Zoom into each container in turn, show the components, and then optionally show the classes that live inside those components. So if you go to my website, go to my book, I can refer to this as C4, and basically it's just about drawing different pictures at different levels of abstraction. That's it, nothing more. Just a quick side point, this is only about static structure. So I'm not talking about collaboration diagrams, I'm not talking about deployment diagrams, you know, those things also add value. So for the purposes of the slides, which are already available to download, here are some examples from previous workshops and training courses that I've run. So here are some context diagrams, you know, they show the thing we're building, systems, users, that's it. Some containers diagrams showing high-level technology choices. They're all boxes and lines pictures, but all quite simple. You know, really nice, easy pictures for developers to understand. You know, where do we write code? Oh, in one of these boxes. Brilliant, we're done. Component type diagrams, and so on and so forth. So I'm not trying to create a standard here, I definitely do not want to do that, but all I want to do is provide some organizational ideas and techniques that teams can use to visualize the systems that they're building. That's it. Also in the book, there's a whole bunch of tips around, you know, drawing boxes and lines type diagrams. If you use UML, you don't need to follow these guidelines because you get a standard formal notation. When I asked the question of how many people use UML this morning, there were like 8 people, so what's that, 10%? So for the rest of us, we need to follow some guidelines. And these are the kind of things we need to look at and answer when we're drawing our own pictures. So if you can understand these kinds of questions, if you can answer these kinds of questions, then your diagrams will make sense. My key piece of advice, start from the top and work into the detail. So, I've gone off on 2 tangents here. I showed you a load of random pictures about Jersey, and now I'm telling you to draw pictures. So to tie these things up, from my point of view, diagrams are maps to navigate the code base. So, you know, you're joining a new project, I can drop you in the 50,000 lines of code and say, go explore. And that's fun, and it's cool, but it's going to take some time. Imagine you had a nice little picture and said, you know, this is how the components hang together. Maybe we should start here. So it's a nice way to navigate the code base, to give you that nice high-level overview. Right, traveling. Let's go traveling again. Let's jump on the other thread. So if anybody ever goes to Jersey on holiday, which you should because it's beautiful, especially in summer. I wasn't paid to say that, by the way. At the airport, or the harbour, you can pick up this map, and it's a visitor map. And it will basically tell you where you need to go. It's got the major sites on there. It's much like the Google map without the satellite view. You know, it's telling you all the major structural areas, the major roads, the major features, the major sites of interest. It's not showing all of the detail. So it's a very detailed sketch. You know, it's not a photograph, it's just a sketch, it's a drawing. It's an abstract representation. And it's good for a very general type of audience. You know, people who just want a quick overview and want to go and explore. It's about getting them on that journey. So here's a couple of screenshots, examples. Roads, major features, bus routes, you know, all the important stuff that you really need to know. There's also a zoomed-in version of the main town. So again, you can see where the major roads are and that sort of thing. Some people want more than this. So for those people who go hiking, walking, mountain biking, that sort of thing, you want more information. You want details about terrain, about altitude, about steepness, all those kinds of things. So, you know, we have ordnance survey maps for that. And these are very, very accurate models. You know, airplanes fly over, they do all the plots, they have people walking around with compasses and measuring stuff, and then all of that really detailed data goes into the ordnance survey maps. So you can see by the complexity of that picture, there's a lot more stuff on there. You can almost see individual buildings and houses. So this is a very detailed model for a very specific type of audience. The thing both these maps have in common is they show points of interest. You know, I'm walking around Jersey, there's a ton of buildings, there's a ton of fields. Half of them are empty, half of them aren't interesting. I really want to focus on what's important here. So, back to software. Unless you go home after the conference, you write your open source code, and it's only this ever going to be using it, whatever you do is not going to live in isolation. Your software systems are not going to live in isolation. And there's a whole bunch of people around an environment and an organization that need to know something about what you're doing. Development team now and in the future, support staff, database administrators potentially, other teams, you're integrating with other teams. Some of my systems have to be reviewed from a security point of view. Sometimes we have to do compliance and risk reviews, that sort of thing. So these people need different levels of information about your system and what you're doing. So whenever you are drawing pictures, keep the audience in mind. So the context picture I briefly showed you, that's really good for a non-technical audience. The containers pictures, the components pictures, they're good for a detailed technical audience. So let's go traveling again. I'm going to show you some photos. When you go to Jersey, and you should, because it's beautiful, and I said that already, I'm going to say it again, you'll walk up to some nice old building and go, that looks cool, but what is it? So we have this castle on the south coast, and it's kind of cut off at high tide, so it's like a mini island. And it was built in the 15th and 16th century, and it's built with really, really nice granite stone. You know, stunning building. Now, you kind of pay your money, you walk over to this castle, you have a look around. At some point, you'll see something which just seems really, really odd. So we have all these beautiful granite buildings, and then suddenly there'll be this big concrete thing stuck on top. So a beautiful granite building, and this big, ugly, concrete dome thing stuck on top. Any thoughts on what that is?
Built by
built by the Germans, yeah. So it was built by the Germans in World War II. Basically, they took all the old medieval fortresses and things like that, and they stuck big gun emplacements on top of them, because they were the best place to defend the island from attack from the British. So a lot of this is really about history and culture, and as you walk around the castle, you'll see placards and leaflets about the history and how all these things came to be. But where do you get this information about history and culture from? So when you guys go on holiday, what do you do? What do you take with you apart from all your luggage and all that kind of stuff? Guidebook, right. And a guidebook has a bunch of really useful information. So there are guidebooks about Jersey, and there are a whole number of them on the market, which is surprising given it's such a small island. But these things have a lot of, 4 things in common essentially. They all have maps. So maps tell you how to navigate, how to get around, points of interest. They have things like sites and itineraries. So you should go and see this thing, make a route of it. Here are the interesting things you can string together in a kind of day tour. It has information about history and culture. So, where did Jersey start, how's it evolved through time and so on. And it's got practical information, currency, types of plugs, all that kind of stuff. So guidebooks, physical, you can also get them online as well. So there's a whole tourism website dedicated to exactly the same material. The thing in common is that they have selected highlights. Again, they're not showing you everything, they're just showing you the things you think you want to see, the important stuff. So back to software again. I said at the start that we don't write documents anymore. But if you look back a number of years, people did write huge documents. And how many of those documents were A, kept up to date, and B, relevant? And the answer is, probably not many of them. So this is a sample architecture document that one of my friends stole from somebody. I did say that on camera, obviously. And it's fairly typical, you've got a bunch of diagrams in here. Some of the diagrams look fairly awful, a lot of text. How much that's actually useful? How much of it was ever read? Well, I'll show you. Probably not much. So this brings us on to our friends, the software architecture document. And if there's only one document I ever produce during a software project, it's one of these. So I may have requirement specifications or user stories or cards or things like that, but if there's one deliverable document, it's one of these. And what does it contain? For me, it contains 3 basic things. It's a summary of the drivers, so the context, the requirements, the constraints, and how we got to the architecture of the solution. It's a high-level description of the software and the hardware and the infrastructure. So it's a description of the software architecture. And it has some information about deployment, operational support, maintenance type of things. Now, I really, really dislike this name. I'm going to go right to sad. Yes, you will be sad by the end of it. Now, if you go look up software architecture on Google, you will get my site as one of the first hits, which is kind of frustrating now. But again, I think there's lots of good stuff that we can take out of your traditional SAD templates. So I've really been struggling. I'd like to give this thing a new name, a new lease of life, and try and get teams writing some documentation. Because after all, some teams do have a duty to deliver more than just the code base. So what should we call it? I think we should call it a guidebook. Let's take that same approach, let's produce a high-level, abstract overview of what software is all about. Something that's quick, short, easy to read, easy to digest, something you can dip in and out of as needed. What should a software guidebook contain? I think it should contain maps, pictures, ways to navigate the code base. That sounds like a good idea. Sites and itineraries. On every software system, in every code base, there'll be some really cool stuff, and there'll be some really boring stuff. So if you're building some sort of website, maybe your MVC framework's the boring part, but maybe there's some cool calculation type component which is doing all the magic, and that's where people really need the information. History and culture. Some software code bases look like two code bases jammed together. And often that's because there's been an organizational change, or the architect has quit, or somebody's found out some new cool way of doing something. And then the whole principles and style of the code has changed overnight. So maybe just documenting that fact is useful. We've got one system, this bit here is a bit crafty and old, this bit's all cool and new. Let's explain the history there. And practical information. How do we build this thing? How do we support it? How do we configure it? How do we deploy it? What are our principles? When we write code, what sort of conventions and styles should we follow? I don't want to get into the too long didn't read camp here. So what's my key piece of advice? My key piece of advice for writing documents is very simply this. Describe what the code doesn't. That's it. Right, this sounds so obvious, yet the number of documents I see where you've got 50 pages which just list out database tables, and they give you a description of every goddamn table, and then they list out every column, and every data type for every column, and every length of every column, and every description for every column. Like, why? The people who understand that information are technical people. The technical people know where to get that information. It's in the database. It's in your domain model. It's in your code. So let's not focus on that low-level technical stuff. Let's keep it higher. One of the things I like about Lean and Agile, Lean's about reducing waste, and Agile's about adding value. So let's apply the same technique to software documentation and just produce something. And let's use our documentation as a way to navigate the code base. Because then when we get new people on board, or we hand over the system to other people, there's a way for them to understand it quickly and easily and efficiently. Which means we can now move fast again. I don't know about you, as software developers, I tend to like exploring code bases. I'm not downloading every open source code base like every night and churning through it, but it is quite fun to look through code bases. It's getting a bit magical in some places now, where you've got annotations doing random stuff behind the scenes, but it's nice to explore. The thing with exploring is it does take some time, and you do need to put some conscious effort into doing it. So again, it backs up my point about, it's the technical people that like exploring. So let's not write all that deeply technical stuff down. Certainly not at the very low level of detail. So, if I was writing a software architecture document, a software guidebook, today, what would go in it? The first section is simply a context section. What are we doing? Who's using it? How does it fit into our existing organization? I've read and reviewed a number of architecture documents in the past, and you get halfway through and you've no idea how it fits into the organization. So let's make that the start. What's this picture? It's a context diagram. So again, let's learn how to draw these types of pictures. I might then summarize the functionality, maybe a really high-level use case diagram in UML, maybe a bunch of activity diagrams if I'm doing something that's kind of process-oriented, automated workflows, something like that, just to summarize the high-level requirements. When I talk about architectural drivers, I'm really talking about things like requirements, functional, non-functional constraints. So let's write all of those things down. So I want to write the non-functional requirements down. Why? Because people will never ever give them to you, and you always have to go and explore and find them. So create yourself a checklist and just write the non-functional down that you come across. Performance, scalability, security, whatever. And if any of these are really significant to your architecture, just make a note of it. Make it shout out that this thing, security, is really, really important, and here's why. Ditto the constraints. You're working within constrained environments, you have existing technologies, system integration points, team sizes, budgets, etc. Just write down the constraints somewhere. Why? Because first of all, they drive your architecture. This is key, crucial information. And secondly, somebody will come to you in a year and say, why did you use WebSphere? And then you can point to the document and say, we had to because it was one of our organizational constraints. Ditto principles. So if you're adopting principles to ensure consistency of approach, layering principles, high cohesion, low coupling, building stateless components, whether you're using store procedures, not using store procedures, whether you're following ACID, the CAP theorem, all of this stuff, just write it down. If you have an existing development wiki, development practices, just refer people to that, but at least write that down somewhere so people can find it. I want to have a nice big picture section. I want to describe what my software systems look like from a very kind of big picture point of view. So my containers diagrams, my components diagrams, they fit really nicely into this section. This is a section I can show developers when they're coming on board and say, right, this is our system, these are the containers and components and technologies that our system is made up of, and this is basically our map to navigate the code base. So it's answering these kinds of questions, what's the big picture look like and how does this thing work? What's the high level structure? If I'm building something kind of integrationally, so like a messaging hub which is sending messages out to systems and receiving responses back, maybe I'll document that stuff. Why? Because inter-system interfaces, particularly external to your organization, are normally the most riskiest parts of software systems. So let's just get a quick document of those interface specifications down. Let's talk about them from a technical point of view. What are the protocols, formats, schemas that we're adhering to, and also from a non-technical perspective. So who owns the interface definition? How often does it change? How do people do version control, release management? What are the service-level agreements on the interface and so on? Just get some of this stuff written down, the basic information. If you're going to do class-level design for particular components, maybe you want to create your own internal frameworks for making stuff consistent, again, just write that down. So this is a class diagram for the internet banking system that I worked on. And on the internet banking system, when a user goes to do a number of different tasks, sometimes those tasks are broken out across multiple web pages, multi-stage wizards and that sort of thing. And we wanted to very, very simply make sure that all of those wizards were built in the same way. So we built a quick framework. I know people hate frameworks, but we built a small framework. And this diagram describes it. There's a half page of text, but basically this diagram describes it. The unshaded classes are provided by the framework, and the shaded classes are the things that you have to provide concrete implementations of. That's it. Anybody spot anything a bit weird about this class diagram? A lot of the component, a lot of the class compartments are empty. Even right at the top, they're empty. It's a summary. This isn't something I've just auto-generated from my code base. This is my interpretation of what we should do here with the information that we need to present to people. So it's worth putting some of this lower level detail in if you're doing it for a specific and very good reason. Visio diagram showing infrastructure and networks and things. This isn't really my area. I'm a software architect, I write code, I don't go build infrastructure. As a software architect, I need to understand this kind of thing. Why? Because I'm crafting software components, I need to make sure they're going to work on this infrastructure. Normally this infrastructure is provided for me by some sort of infrastructure architect or infrastructure team, for example. So by including an infrastructure diagram in my documentation, it forces me to go through that thought process. And really what I'm asking here is, what does the physical infrastructure look like? So what servers, routers, firewalls, load balancers do I have? Even if you're using Amazon EC2, you can draw that stuff out. And does it support what I'm doing from a software architecture point of view? Does this architecture support my architecture? It's really useful information. You have your software components and you have your infrastructure components, and there's a mapping between the two, isn't there? So you take your web server, you deploy it on a physical piece of kit or a virtual piece of kit or something. You take your web server and you spray it across your farm. That's a very different mapping. So I always have a section in there which talks about the deployment of those components and how we do that. So it's talking about deployment of components, it's talking about configuration of components and that kind of thing. I'll usually have some sort of operational view. How do people operate, support, run my application? How do they manage it? Where do logs go? How do people diagnose problems? Sometimes this section will get broken out into another document, like an operational handover type manual. But again, as a starting point, I'll put something in my software guidebook. So you'll notice these sections are sometimes targeted to very specific and different audiences. And that's fine, but at least you've got one place to put all this stuff. Some other optional type views I might put in, if I'm building a system and I know it's going to be security audited, then I'll put in a section that talks about how we're dealing with the security requirements. So how we're dealing with certificates, how we're dealing with physical security, logical security, are we using secure class length facilities in Java, that sort of thing. If I'm doing something very data-centric, then maybe I'll talk about the data model, where the data is being stored, how it's being replicated, backed up, sharded, archived, etc., etc. So again, there's really useful information in there which often gets lost, particularly around archiving and backup. So I worked on a project once, and people knew the data was being archived, but they didn't know where it was going. It turned out it was being squirted into another SQL Server database somewhere else. History and culture, how do we get to where we are? Sometimes you have to evaluate and choose technologies. WebSphere versus Tomcat, MongoDB versus RavenDB. If you go through a spike, some sort of proof of concept to choose one or the other, let's just write that stuff down. Because then when somebody joins a team, they have this massive argument about what you chose the wrong thing. And we're going to rip it all out and replace it with the other thing. At least you can point us to say, well, at the time, this is why we chose the thing we chose. So again, it's just talking about those decisions and the intent and the rationale at the time we made them. And finally, I might drop in a kind of final section which talks about, this is how my architecture works, and this is why it works. So if we have particularly complex non-functional requirements, for example, around performance, scalability, security, then I might write a section at the very end which details how we're dealing with all of those different aspects. This is a graph from a load test, a performance test. Obviously, this requires we write some code, but that's fine. So for me, any software documentation needs to be living, breathing, evolving. This is a one-shot upfront document which gets delivered, signed off, agreed, and then we start writing code. So back to my screenshot Visual Studio. What's the bare bones documentation that I write on every single project? It's a document containing these 9 sections. So the green ones talk about the drivers and how we got here. So context, requirements, constraints, and principles. The red ones talk about the high-level structure, software and infrastructure predominantly. That's the big picture, the maps. And the blue ones, they talk about the operational configuration, deployment type aspects. Reduce waste, add value, describe what you can't get from the code. Let me give you some examples. The software architecture guidebook, or architecture document as we call it then, for the internet banking platform is about 70 pages. That's a team of 4 people over a number of years. I did an architecture document for ASP.NET front end, bunch of web services in the middle, SQL Server, Microsoft CRM Dynamics, quite a big kind of web-facing architecture. The architecture document's about 50 or 60 pages, again with these 9 sections as the basis. I worked on a project for a week. It was a pilot project, and in that week I had to get requirements, have workshops, do the architecture, write all the code, write all the tests, deploy the system, and document the system in a week. My architecture document, 9 sections. I spent the last 2 hours of that project on the Friday afternoon just crafting up the documentation. How long was the document? 10 pages. A cover page plus 1 page for each of these. Did it add value? So I was given a week to build this entire system and deploy it. So it was a pilot, and it was never ever supposed to go live. Of course these things do. A friend of mine got called in to make some enhancements to the system, and I was too busy doing some other work, so I couldn't really help him out. And I said to him, here's a document, and in that document it tells you everything you need to know. It tells you where the code is, it tells you what the high-level architecture looks like, it tells you how to deploy, maintain, all that kind of stuff. If you need me, call me. Never got a phone call. So either quit or it was fine. So yeah, for me, documentation's about having a living, evolving, breathing, additional level of information above the code base. Look, the slide draw. The software architecture document. Sorry, I meant guidebook. So let's do a guidebook thing. Let's keep it lean and lightweight here. Just to wrap up, where do we keep documents? Because this is always a sometimes contentious point in organizations. So my first preference is to keep documentation next to the code base. So first of all, what do I mean by documentation? I'm normally referring to Microsoft Word. And I put it next to the code in a docs directory so that it evolves and lives with the code base. If a developer comes to me and says, where's the documentation? You've already got it checked out. It's in that docs directory. The thing is, if you've got like a stable release and you're branching, you're also branching your documentation. And I really do not like merging binaries, it doesn't work. So if you are branching regularly, I'd recommend creating a separate repository next to the code base where you put your documentation. So we've had to do that a number of times. It doesn't have to be Microsoft Word. You could use HTML or Markdown or some other, plain text type format. So again, if you do use plain text type markups, then branching and merging it is much, much easier. But I would suggest you don't want to be merging and branching documents. So I work in a consulting environment. This is my preference because I can find the documents easily. My customer's preference is completely different. My customer's preference is to stick on a network share or SharePoint. Who likes SharePoint here? Nobody. I did not bribe you to say that. So, my customers tend to like their documents somewhere a bit more central and searchable and easy to find and have security and that sort of thing. And that's fine, why not? This is much, much better when non-developers need access to your guidebooks. If you've ever explained to a non-technical person about how to check something out from a source code system, it's a nightmare. So my other preference is to use a wiki. And there are a number of people out there who do this kind of guidebook approach on their wikis. The great thing about wikis is that, because the barrier to entry is so low, people can just go onto a wiki and start writing stuff about their software. The downside to wikis is exactly the same. So because there's a low barrier to entry, people can just go and write garbage on there. So you do need to clean up your wiki and prune it and make sure it kind of makes sense. So what I've seen teams do is they've taken my kind of 9-section guidebook approach and superimposed that onto their wiki. So they know where to put stuff, where logically to find things as well. So that can work really well. So think about introducing some structure to your wiki if you're going to do that. Who's heard of the dry principle? Do not repeat yourself. So I will repeat myself. And to repeat myself, I'm going to say this. The code doesn't tell all of the story. It tells you a story, but not all of it. So your code, is the most specific version of the truth, but it doesn't tell you stuff like, where logs go, what the big picture looks like, how to deploy the thing, how to build the thing, etc. So there's an additional level of information that you need on top of the code base. So, in my opinion, all software teams, whether they're agile or not agile, should be producing some sort of documentation. And they should therefore be delivering the code base plus a software guidebook. a lean, lightweight, thin guidebook which expresses all of that other stuff. So let documentation describe what you can't get from the code, and use diagrams as maps to navigate the code base. This is how we can really start to move fast on our project. Thank you very much. So then we've got a couple of minutes for questions, if there are any. Yeah?
When should we create this document?
So as soon as you possibly can. So the question was, when should we create this document? As soon as you possibly can. So when you start the project, you should start understanding the context. Who's using it, what are we going to integrate with, and so on. So that first section, you can write right at the start of your project, and then just keep evolving and adding to it.
Who's responsible for this document?
Who's responsible for this document? So on my project, it's normally me, because nobody else will do it. So if there is a master builder on your project, if there is an architect, that should be a part of the role. If you're distributing the architecture role amongst many people and you're self-organizing teams, then it's everybody's problem. So this is a good reason to start sharing the role out, doing pair architecting and things. Any other questions?